Problem number 8 provides a new wrinkle. We are not given any limits, just the two functions, 4 minus x squared and y is equal to x squared plus 2, and we're rotating along the line y is equal to 6. Just like in problem number 7, that means that we're rotating around a line that's above the two functions. So the shape that we get is kind of like a lifesaver. I don't know. We have the inner function is the one that's closest in this particular region, which is 4 minus x squared, and the outer function is x squared plus 2, which is the farthest away in this region. By the way, the region is formed by the intersection between these two curves. The intersection points occur at x is equal to -1 and x is equal to +1, and that forms our region. There is no other region which would fit in that would be enclosed by the two curves or bounded by the two curves. So, in this particular situation, you want to be very careful about setting up your integrals. In this case, the outer function is y is equal to x squared plus 2. The line is on top, so it needs to go first inside of our square. So we would do 6 minus x squared plus 2. Make sure you put parentheses around your function so you don't lose your negative. Again, integrating and multiplying by pi. That would give us our outer radius, or the volume of the solid created. The inside function, the inner radius, would be 6 minus 4 minus x squared, the difference between the two functions. Again, we're integrating from -1 to 1, and we multiply by pi in the long run. One word of note, if you get a negative volume, one of the first things you might want to check is to see whether or not the functions have been written in the wrong order. It's not always the case that a negative volume means that you just need to switch which function goes where, but oftentimes it is. Plugging this into our calculator, we get 50.265.